So right here I have a differential equation that is both separable as well as first order linear. So for our purposes here, I'm gonna solve this as a first order linear differential equation. So the first thing I'm gonna do is I'm gonna multiply out my dx. And after multiplying out my dx, I get that dy minus tan x times y dx equals 1, or equals dx. And I'm going to actually rewrite this. I'm going to say dy plus minus tan x times y times dx equals dx. And the only reason why I rewrote that in that way, it's very simple algebra, was just to make the integrating factor a little bit easier to evaluate. So our p of x is what I have here circled in yellow, this minus tan x. And to evaluate the integrating factor, I'm gonna say e to the minus tan x dx. I'm not sure why I changed colors here randomly, but that would evaluate to e to the minus, what's the integral of tan x? The integral of tan x is negative log natural cosine x. So the two negatives actually cancel each other out. So that's e to the ln cosine x. And that just simplifies to cosine x. So I have it that my integrating factor is equal to cosine of x. Let me change my color here. So after multiplying all this by cosine x, and I'm not sure why the color's not cooperating, a little bit weird, but the multiplying, got back to this color here. After multiplying everything by cosine x, I get that dy plus minus tan x cosine x times y dx equals cosine x times dx. And based on everything I presented in the previous video, this would be the total differential of cosine x times y, and it would be equal to cosine x dx. So here's all that I've gathered from the solving of this differential equation, and I end up with the total differential of cosine x times y equals cosine x dx. And so I can integrate both sides, and the integral of a differential is just the function. So cosine x times y equals, what's the integral of cosine x? The integral of cosine x is sine x plus c. So sine x plus c. And now we get that y is equal to sine x over y is equal to cosine x, or because we're going to divide the cosine x, so we get that y equals tangent x plus c times secant x. I'm going to just invert the cosine x. That'll just give us secant. Makes it a little bit simpler. Or you could say c over cosine x. They'd mean the same thing. So c times secant x. And while normally in integral calculus, when you evaluate an integral, you end up with the constant of integration not being multiplied by any function. But in this case, that's not the case. This time, well, a lot of times with first order linear differential equations, the constant of integration ends up appearing somewhere where you typically probably wouldn't see it in Calc 1 or Calc 2. In this case, it's being multiplied by secant x, and so if you're solving an initial value problem, that becomes very important. And it's a big thing that you really shouldn't forget. I feel like it's an easy room for error.